So this question involves two variables, x and y. And x is manipulated by some system. So if you imagine that you have some system with an input and an output, x of t is your input and y of t is your output. Then the question is telling us that y of t is x of t cubed. And the question isn't asking us to find x in the frequency domain. We don't need to find that. The question is asking us to find y in the frequency domain. So the first step is to find y in the time domain. So the first step is to do that. And to do that, it's really straightforward because we know that x in the time domain is e to the minus 10t times u of t. So what that looks like is something like this. So it's a decaying exponential. That's your input. The output of this system, y, is simply that cubed. So it's e to the minus 10t times u of t cubed. So what happens when you cube an exponential? Well, you multiply the power by 3, and that doesn't change because u of t simply means that it's 0 for all negative time. So cubing the unit step is like cubing 1. It has no effect. So this is y of t. Now the question is asking us to find y of omega. So y of t and y of omega, these form a Fourier pair. And the question actually tells us, in the question there is an expression for the Fourier transform of a decaying exponential, and it's simply 1 over a plus I omega. And in this case, a is equal to 30. So our final answer would be y of omega equals 1 over 30 plus I omega.